Fine. But before we start, Manshi, I have seen your answers, what you have done with your some other exam. Here, what is that exam here?
Sir, which exam?
You have sent some homework to me, na? Do and come.
Graduation exam.
Huh?
Graduation exam.
Graduation. Sir, the way you answered was really beautiful. I clearly can make out you understood every concept, and the way you presented the concepts in your answer paper was also good. Okay, it was up to the point. I really appreciate you for that.
Thank you, sir.
Okay, fine. Next. Sir, how many of you ever waited at an airport to talk to a pilot to ask him, okay, like I want to become a pilot. Uh, where should I go? Anybody waited at an airport? Tanisha, you waited? Which airport? Chandigarh airport?
Yes, sir.
Okay, so what a coincidence. Okay, so I was working in PGA Chandigarh for some time. I was at the same airport. You know, Chandigarh airport is kind of Air Force base. So the number of aircrafts coming there were very less. I went to this airport morning 9 o'clock. I waited. It's like 12 o'clock in the afternoon. Nobody came out. I could not see any pilot. So it was like still I waited. It was like around 2 o'clock. Then I thought, yeah, today probably I don't know whether pilots come out of this airport or not. I will leave. I will leave. So just I was like looking, you know how Chandigarh airport is, correct? It's a small airport and you have a lot of auto wala, taxi, this thing. I don't know. I have not visited in some years, but it's like a very small entrance. So I was just looking for the auto guy and I was doing this. So just behind me, I noticed a white shirt passed and I took a look, okay. So he was a pilot with his bags and all. So I said auto wala, no. So that guy came from there, from that auto driver. So I said, no, no. Okay, fine. So he left and I was talking to this pilot. I said, do you have some time? Like I introduced myself. I work in a nearby hospital. I'm really interested in like, I really want to do this since a long time. Probably now I can afford it. So I want to go for it. See, back then, there was no YouTube. So there was no Instagram. Okay. All mobile phones were this, what to say, they look like a calculator with few buttons. I believe you all would have seen, correct? But imagine where we had only landlines. When I was small, there were not even landlines. Okay, when I used to study at a hostel in my, uh, if I have to talk to my parents, I have to write a letter, post it, and that letter will reach my home in 2 or 3 days. Then they will write a letter when they are going to come to hostel to see me. Okay, so the one communication used to take around like few days, probably 3 4 days. Now, because there were no mobile phones back then, I asked him how to do this, how to go about this. He was like very cool. He was very cool. So he gave me a detailed thing how to get into this thing. So back then, how he did was, so there was an exam. Okay, back then there were government exams which used to sponsor CPL. For example, I am a government student with my medicine. So all my medicine was free of cost. I had to pay only 10,000 rupees per year. That were the charges which I paid when I was doing my MBBS. And then in MD, they gave me salary around 70 to 80,000 rupees per month. Okay. Now, the thing is, this CPL was also like that. Long back, long back. When this guy was very old captain, not very old, he looked smart. So he said, see, back then it was the scenario. And now the scenario is, he said, you have to do your CPL on your own. Now it is very bad. So he said, okay. So we sat down there and then like he explained me on a piece of paper everything. And once you complete your CPL, airlines will do your type rating and they will take you as a pilot. Okay, so this was like 2000, very 2000s. Okay, so it was like where some of the airlines, once you have a CPL, they will do your type rating, airline training, and take you in as a pilot. But now the current scenario is you are doing your type rating. Okay, like if you take like 8 years back, you are doing your type rating. Now the current scenario is you are doing your type rating, correct, and they are also asking for a huge amount of money for the airline training. Correct, because see, there were the number of pilot people who were able to afford pilot training were very less, so they were offering everything. Now it's like number of students who are pilots and they are sitting at home are more when compared to the demand, so they are taking money from us to give us the jobs. Okay, so and then after that, one day I texted him, shall we go out? Like we became friends. We used to go for morning walks. He used to live near my PG only. I used to live in a PG in Chandigarh. So one day I texted him, shall we go out? Yeah, why don't we meet over a dinner? Okay, so we met over a dinner, and he told me a beautiful story, which was very inspiring. Okay, this story was very much inspiring. Okay, so today I'll teach the entire class based on the story. Okay, so this captain's name was Arjun. Okay, I did not name my son after him. I named my son after the movie Arjun Reddy. Okay, so yes, let me share my screen. Okay, so when this guy joined an airline, and this guy joined an airline for the first time, so he was flying from, he said he was flying from Chennai to Colombo. Okay, so he was a very first this were very this was very much initial part of his career, so he was very fresh into the airlines. In like during that time when he was very fresh and he was trying to figure out most of things on the aircraft, what happened one day, his captain on the aircraft, he said he had severe chest pain and he went unconscious. This is what he said, he described it. So that captain had a severe chest pain, he said, oh, and he went unconscious, I don't know what to do. Okay, so this was the story he was telling. What happens here, what is the first thing you do as a co-pilot when your captain becomes unconscious or he enters such a thing?
Inform
Huh?
inform the ATC.
No, see, you
Take
will
over the
ask
controls.
the cabin crew to look if there is a doctor on board. This is a standard protocol. First you have to look if there is a doctor on board. See, imagine I am the first officer. Okay, 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 make him lie down, 2-3 tablets. Okay, wake up, come fly the aircraft, do the lab. Okay, see, he is not a doctor. So thing is, like, he has to take some action. Now, see, before every flight takes off, there are a few signs the captain does, and the first officer also counter signs. See, one of them is a paper called CP. Correct. So that day he also told this guy, Raghu. This was the dispatcher. This guy gave him 2 documents to sign. One of them was about critical point. Let's assume this aircraft is going from this point to this point. Okay. See, from now on, okay, listen to the terminology very carefully. I'll be using this terminology repeatedly, and you should also use the same terminology when you're solving questions or going for your exams. Okay, so place from where you start is called your departure. Clear? Place where you go is called your destination. Correct. Now this track, if you're going from departure to destination, this track is called as outbound track. Am I clear on this? Now, for some reason, you turn around and fly like this. You're going towards your departure. This is your home, correct? This is called as home bound track. Are the four terminologies very clear? Okay. So this Raghu gave him 2 documents to sign. One of them was saying about critical point. So let me explain what is a critical point. A critical point is a point between departure and destination. On track, there will be a point. If this is your track, on the track, there will be a point. Let's assume this is the point. From here, if you continue your journey towards the destination, or if you decide to turn around and fly to your home or departure aerodrome, the time taken, let's say this is T1 and let's say this is T2, the time taken will be same. Okay, so critical point is a point on the track from which time taken to go to destination or departure. Will be same. It means if you go forward also or if you go backward also, correct? Both time will be same. How many of you understood what is a critical point? Correct. No. For example, today let's assume there are no winds at all. He is going from Chennai to Colombo. This is Chennai, this is Colombo. Correct. In between these 2 places, on your way, there are no winds at all. Now tell me, where is that critical point from where if you go home or continue outbound, correct? Go to your departure place, that is home, or continue towards your destination, time will be same. Where will be that point? Let's say between the departure and the destination, the distance is 1000 nautical miles.
At midpoint.
500.
500 nautical mile.
Very good. Very good. Very good. At midpoint. Okay. So at midpoint. Very perfect. Very perfect. Now, see, will it daily lie on the midpoint only?
No,
Can someone
sir.
say
It
why?
depends
Can
on
someone
the-
think and say why?
Depends upon wind direction.
Very good. Very good. See, for example, if there is wind, let's say today there is headwind. Okay. Now, if this is the midpoint, if you continue forward, winds are trying to push you back. Correct. So from midpoint, it will take a lot of time to go to your destination. But when you turn around, see, winds are helping you to fly faster. Henna? So you will reach your departure faster. So is the time same? No. Correct. So critical point or the point from which the time is same, T1 and T2, will depend on the winds. Correct. Now, see, I'll teach you this. I'm very excited to ask you how many, I want to really check how many of you can put your brains into this. Now, for example, if the winds are headwinds. Okay, so if the winds are coming like this, now this is the midpoint. Tell me whether the critical point will be closer to destination or departure. Think and tell.
Destination.
Destination.
How many said destination? Excellent. Yeah.
Where the wind's coming from again?
Very good. Excellent.
Towards destination in
Yeah.
case of headwind.
Yes, towards the destination. Very good. Very good. Why? See, let's say you are here, midpoint, correct? If you're flying back to the departure, the winds are helping you to move forward fast. So towards your departure or towards your home, you are fast, correct? So this is not the point. Here you are slow. To the destination you are slow. So if I take here, okay, let's assume the CP is here. Okay, if I take a red color, if I assume CP is here, this is taking too much time, this is taking too less time. So CP cannot be on this side. So if I take CP here, see, this direction you are fast, but the distance is more. This direction you are slow because of headwinds, but the distance is less. So somewhere it will balance and the CP is towards the destination. How many of you understood this? Okay, here I have made a separate slide to make you understand this point, but most of you could answer this, but we will discuss it again. You may just note down. CP is closer to destination if you are facing headwinds. On your very good, guys, very good, you're doing excellent. Okay, now see, this Raghu gave how many documents? 2 documents. One document is CP. That means Raghu said, see here, if you are taking off from, let's say this is Chennai, correct? So after let's say this is the CP. Let's say CP is at 600 nautical miles from Chennai. Okay, that means he said here, if something happens like this, if you are before 600 nautical miles, you turn around, it will take less time to come to Chennai. But if you are beyond 600 nautical miles, you can go and land in, you have to go and land in Colombo if you have to save time. Now tell me what happens if you are exactly at 600 nautical miles, where you have to go, whether you have to go to Chennai or Colombo.
Anyone should.
You can go anywhere. For example, your captain is having a heart attack, correct? Let's assume, yeah, Manji, your voice is very slow. I mean, your internet connection is problem. Be on mute. If you have anything, you please then unmute and ask. Okay, fine. See, you can go anywhere. For example, in this case, let's assume Chennai has a hospital, but that hospital is very far from the airport. It is going to take a long time. But in Colombo, in your destination, the hospital is very near to the airport, correct? So if you are at 600 nautical miles, you decide to go to Colombo because of that other reasons. Clear? It's up to you. Till here, any doubts you can ask me.
Sir, let's say we are at 600 nautical miles, right? Will the turnaround will impact the time? Like
No,
I have to turn the aircraft, no that?
No. Assume that turnaround time is 0. Okay. See, here, generally, it will not take much time for an aircraft to turn around. Probably you are doing a rate 1 turn. Rate 1 turn is how much, guys?
3 seconds.
3
3
degrees.
degrees per second.
3 degrees per second. Okay. So if you have to turn 3 degrees per second, and if you have to turn 180 degrees, how many seconds it will take?
60.
1 minute.
1 minute here. It's okay. Am I clear? Because all airliners do only rate 1 turns. Shall I move forward? Next. Now the question is, how did Raghu know, who is a dispatcher for this aircraft, that CP is here? Is he flying the aircraft? That means he have somehow calculated sitting at airport. Correct? That means there is a way to calculate these things sitting at the airport. Shall we do the calculations? Correct. Shall I show you how Raghu knew it was a 600 nautical miles?
Yes, sir.
Okay. Now, see. Let's assume this is your departure, or in this case, Chennai. This is your destination. Okay. I'll assume the total distance between departure and destination is capital D. Can I assume that? Okay. So there are winds today. I don't know how much are the winds. Okay. I'll assume my CP is here. Critical point. Now, can I assume the distance between departure and the CP is small d? Now tell me, what is the distance between the CP and destination?
Capital D
Capital
minus
D
small
minus
d.
small d.
Very good. Capital D minus small d. Okay. Now, let me ask you one question. Okay. Think and answer. Guys who have attended instruments, so they will answer anyway. Correct. Guys, you who have not attended instruments till now, you have to think and answer. Yeah. How many of you know what is the difference between TAS and ground speed? How many of you doesn't know what is TAS and what is ground speed? Raise your hands. Okay. I'll go back. Probably new thing, because I have to explain you what is a TAS. See, let's assume an aircraft is flying. Correct. Now, it is flying from, let's say, Delhi to, let's say, Hyderabad. Okay. Imagine there are no winds today. It means winds are calm. Okay. Now, as the aircraft moves forward, air molecules are being disturbed because of the wind blowing over the aircraft. Correct. Now, at some distance, there will be air molecules which are very much undisturbed because of the aircraft. Correct or not? Okay. Now, see, let's assume with respect to this air molecules, the aircraft is moving forward with, let's say, 100 knots, 100 nautical miles per hour. How many of you understood this? Okay. Now, are these molecules moving today? No, because there are no winds or nil winds. Correct. That means here, with respect to, if there is a building here on the ground, with respect to building, what is the speed of the aircraft?
100 knots.
100 knots or 100 nautical miles per hour. Correct. Because see, with respect to the building, these air molecules are not moving. Correct. How many of you understood till now? Till now. Okay. Now, see, TAS is nothing but the speed of aircraft with respect to a nearby air molecule which is undisturbed due to aircraft movement. Am I clear on this? What is TAS? Okay. Now, for example, today all the air is moving in the same direction as your aircraft with a speed of, let's say, 20 knots or 20 nautical miles per hour. That means, see, let's assume your TAS now is again 100 nautical miles per hour. That means with respect to this air molecule, your aircraft is moving forward with 100 nautical miles per hour. But all the air molecules are pushing you forwards or taking you forward with a speed of 20 more nautical miles per hour. How many of you understood? Okay. Now tell me, with respect to this building on the ground, what is the speed of the aircraft?
120.
120 nautical miles.
120 nautical miles. Correct. So in first case scenario, when there are no winds, okay, so TAS was 100 nautical miles per hour. Now in second case, sorry, in the first case itself, the ground speed was what? What is the ground speed in first case?
Equal to test 100 nautical mile per hour.
Very good. How many of you understood the nil wind scenario? TAS is equals to ground speed. Why? Because with respect to ground or a building on the ground or something like that, the air molecules are also stationary. Very simple. Correct. Now, second case scenario where you have tailwinds. See, if the winds are coming on your tail and pushing you forwards, these are called as tailwinds. Okay. Now, tailwinds, you have 20 knots. Now, what is the, assume the TAS is same, 100 nautical miles per hour. Now, you are moving with 100 nautical miles per hour in this wind, but the whole wind is carrying you forward at a speed of 20 knots. Correct. Now, what is your ground speed?
120 knots.
120 knots or 120 nautical miles per hour. Am I super clear till now? Anybody wants me to explain? Sir, you, what are you explaining? You don't know how to explain. Anybody has that kind of intention? Okay. Anybody wants me to explain again? I'll explain. No? No? Then I'll ask a question. Will you answer? Okay. Now, your TAS is 340 knots. Okay. Your ground speed is, let's say, 300 knots. Find the wind.
Headwind of
40 knots.
40 knots.
40 knots.
headwind.
Very good. You're trying to move forward. The winds are trying to push you back. Correct. This is called as headwind. Correct. So headwind of how much?
40 knots.
40 knots, because you're moving forward with 340. The wind itself is taking you back with 40. That's why your ground speed was only 3. Correct. Now, listen carefully for next 1 second. Next, no, 1 second is already over. 1 minute. Okay. See, headwind will decrease your ground speed. Correct. So when I say today winds are minus 20 knots, if you see this in exam, you have to understand the wind speed is 20 knots and it is a headwind. Understood? So headwinds are generally represented by minus, and tailwinds, let's say plus 30 knots. That means TAS is something and tailwinds are pushing you with extra 30 knots. So your ground speed will increase. So tailwinds are generally represented by plus. So because like DGCA, so some guy would have copied this question paper from EASA or Oxford, correct? So where they would have used this kind of symbols. Okay, so this is some kind of standard to use minus for headwinds and plus for tailwinds. Is this clear till now? Now, is there anyone in this room who doesn't know what is a TAS and what is a ground speed? Everybody understood? Okay. Shall I ask you a question? So Delhi to Hyderabad, let's say it is 1000 nautical miles distance. Okay. Your TAS is, you're flying A320 340 knots. Okay. You have a headwind of 20 knots. Okay. Your distance from Hyderabad to Delhi. Find the flight time. That means how much time it will take after you take off to reach Delhi.
3 hours.
3 hours, 7 minutes.
I want exact answers.
3 hours, 7 minutes, 30 seconds.
Oh. Huh? 3 hours, 7 minutes.
7 minutes. Yeah.
So how did you calculate?
From ground speed.
Okay. See, you're going from Hyderabad to Delhi, correct? Now, let's say this is the ground, correct? Here, when you are calculating time, are you traveling distance on ground, correct, with respect to ground? Because see, from Hyderabad to Delhi, it is the ground distance you are covering, correct? Understood? So that is the reason when you use distance is equal to speed into time, correct? This speed is nothing but ground speed here. Because why? You are inputting distance as ground distance, na? So never take TAS here unless they say nil winds. How many of you understood why you should not take TAS? Okay. Now when I teach in instruments, I will teach you the same way. There is TAS, there is indicated airspeed, there is calibrated airspeed, also called as rectified airspeed. I'll teach what is equivalent airspeed. Okay. And any other airspeed here? Anshi?
Sir, CAS, TAS, IS, ES.
That's all, na? So we will learn all these things in instruments. Today, I have given you a taste what is TAS and what is ground speed. How many of you are very clear of all the concepts till now? Shall I move forward? Good. Okay. Now, see. So, coming back, total distance between departure and destination is capital D. Your distance to CP I have taken a small d. So, from CP to destination, it will be D minus D. Till here, everybody understood? Okay. Now, let's say my engine has, sorry, I have a emergency here. I have to land as soon as possible. Correct. I can go home or I can move forward to destination. So if I am at CP, correct, if I am at CP, the time to go back or go forward is same. How many of you agree? That is the definition of CP. Correct. Now can I say T1 is equals to T2, time to go back? Correct. Now see, the ground speed to go back, okay, I'll represent this ground speed as H. H means home. How many of you understand? So H is ground speed home. I represent the speed of the aircraft with respect to ground, that is ground speed of the aircraft when traveling to destination, or you're continuing like this as O. O is equals to outbound ground speed. This is called as homebound ground speed. Am I clear on this? O and H. Correct. No. So T1 is equals to T2. What is the formula here? Distance is equals to speed by time. Correct?
Speed into time.
Into time.
Anybody doesn't know what is distance equal to speed in time? Raise your hands. No? Okay, distance equal to speed into time. Correct. Now what is time? Time is equal to distance by speed. How many of you understood it? Okay. Now, see. What is T1?
T by H.
Oh, there are two D's here, small d and capital D.
Sir, small d by H.
Correct. So this is the ground distance, small d, and this is your speed. Okay. Distance is equal to speed into time. Okay. So distance is small d, speed is homebound into T1, because I took this as T1 and this is T2. And T1 is equals to T2 because you are calculating from CP. Okay. So T1 is equals to small d by H. Can I write small d by H here? Everybody?
Yes.
Everybody. Fine. What is T2?
Capital D minus small d by O.
How many of you understood? Okay. So T2 is capital D minus small d by H. H or O?
Sir, O बोला है.
So, clear? Now I'll solve this equation. Cap small d into O is equals to D into H minus small d into H. So I want distance to CP. I want this, correct? This is what I wanted. So I'll try to take D in one place. So O, if small d comes H. How many of you understood this step? Is equals to capital D by H, capital DH. So distance to CP is equals to DH by O plus H. Don't write down. I'll have to explain a lot before I ask you to write down. Don't write down. I'll give you time to write down. How many of you understood till now? Okay, now. Here, tell me, I was telling critical point from some time, correct? Tell me what is meant by critical. What is meant by critical?
Serious.
Critical as in critical point from where you need to decide where to go. So it's
Who said serious? Who said serious? Sanisha, you said serious, no? Who said serious? Raise your hands. That means if I get angry, okay, you will say Vamshi sir is critical. Huh? Serious? What is this? Which school here? English teacher? Huh? I'll call her and say. Fine. What is critical? See, critical means, for example, if you take my wife, she is a super specialist in critical care. She deals with patients on ventilators. She deals with every case which is, there can only be two outcomes. One, that case is going to expire. I mean, he or she, the patient is going to die, or he or she get relieved of the disease and going home. For example, if you take a normal general medicine doctor, correct? So you go to his clinic, so like everybody is going to go home, correct? Because like it's a OPD clinic. But here it is like every case is critical. That means here there will be very less time to make sure the body doesn't go bad. Understood? So something which is very much related with time is given a name critical. Correct? So here because see from this critical, see if you are before the critical point, you have to go back. There is no other option. Okay. If you are cross the critical point, you have to go forward and land there. There is no other option. Can someone give me an example, 2 or 3 examples where time is a factor? If not, something bad is going to happen on the aircraft. Time is a factor. Give example.
So when you are having an emergency and you are also gonna run out of fuel.
No.
There's
No. See, fuel is like you're going to land there. You're not going to destination. You're not coming back. Okay. See.
Medical emergency.
Yeah, medical. I have already told.
capacity.
Some
Like
fire.
if you can, yeah, very good. Fire on board. Correct. Engine fires. Correct. You have to land as soon as possible. Okay. If you can land, if you like, for example, you are on a sea and there's a small fire. Correct. See, most common emergency is engine failure, along with medical emergency. See, what is engine failure? See, if you take multi-engine aircraft, there are 2 engines. Or if the jet, there are 2 engines. Correct. For example, if one engine fails, that means it completely stops working. Now the other engine is pulling the aircraft. Correct. Now it has to be on full power. Correct. Now it is consuming a lot much fuel than it should consume. Now, because this engine is not producing thrust, but because of its resistance moving forward, it will create drag. That means drag on the aircraft is much more when two engines were working. So in these cases, here time is a factor. You have to land as soon as possible. Because see, the more time your aircraft flies, it has to burn more fuel to counteract the drag, and your engine is facing so much stress for a longer time, the second engine might also fail. Correct. So when an engine fails on a multi-engine aircraft, time is a factor. How many of you agree to it? How many of you agree to it? You know, let me tell you my scenario, how I do the duties in the hospital. Whenever I go to a hospital, I'll take an over. Over means the senior who has done the duty will tell me about all the cases, what he has, what is happening with that case, and what he has done to the case to improve the patient, and how critical the case is. He will give every over. Okay, so this will take around 1 hour. Okay, I will stand beside the table and we will discuss. Oh, this is the patient came with this thing, so he has BP, this thing so many years. Okay, fine, this is the thing. So he met with the accident a few days back, and probably this leg has got an injured there, then it got infected because he's diabetic, the infection got worse, so on and so forth. I have to listen, I have to remember everything. Now I have like 20 beds to remember, and I note down stuff. Okay, now after that, guess immediately what I will do. Can anyone guess?
Attend patients who are critical. I mean, time factor is.
Juniors, understood? No, I'll go and sleep. I'll go within next 1 hour of my duty, I start sleeping. My juniors are very well trained. They will take over all the cases. They will not disturb me. They have like in 6 months, once I find very good juniors, in 6 months, if I do duties in the hospital, they would have called me like for 10-15 cases. That's all. You understand? So that's how good I have to train my juniors so that I can sleep peacefully in my duty. Now you may ask, sir, you're charging around like 5 lakhs for a hospital, correct? Your hospital is paying you 5 lakhs and you're going and sleeping there. Correct? Hospital can run with these juniors also. No, I'll tell you why I sleep as soon as I get onto a duty. See, I have seen times, for example, how many of you know that in Kerala, there was explosions of these crackers put for some festival? How many of you know that has happened a few years back? Correct. How many of you know that there was a peak in dengue cases and people were coming in tractors to the hospital? Correct. See, we have something in an emergency. For example, if nearby a bus collides with a lorry or something like that. Okay. Now, the number of critical patients coming into the hospital are how many? At a time, you get 50 patients who are just about to die if you don't intervene. Correct. So how sharp my brain has to work. Correct. I'm not sleeping because I'm lazy. I'm preparing myself for the worst when I'm on duty. I've seen worse days on the duty, but till date, no remark. Because when worst thing happens, my brain knows what to do and it is sharp. It doesn't get tired because I have prepared for that scenario even before I started my duty. When I start my duty, I'm going and sleeping, correct? So imagine 50 patients coming together who are all critical, and believe me, I can manage every single one of them. Okay, so the same way, see, you have to fly an aircraft in the same manner. Okay, the engineers who designed these things also designed the aircraft in the same manner. There are redundant systems. That means if one engine fails, there is something, correct? So there is APU, correct? If two engine fails, there is ram air turbine coming out. So same way, here when you are calculating these points, critical points, here you imagine when the emergency happens, one engine always fails. Okay, see, if it doesn't fail, you can aram se come fast and land. But if one engine fails also, you have to know how much time it takes to reach to your destination or departure. How many of you understand the importance of assuming that one engine has failed? Now, tell me, this aircraft, can it fly with the same speed with one engine? No, correct? So when engine fails, aircraft speed reduces. And this speed is called as reduced speed. How many of you understand this line? When engine fails, aircraft speed is reduced, or it reduces. That speed is called as reduced speed. Now, see, I'm calculating the time taken to go to departure or destination. Not me, Raghu was calculating. He was the dispatcher, correct? So Raghu will assume here at this point, the one engine is also going to fail. So the pilot has to fly with only one engine. Correct. So if two engine speed is, let's say 340, one engine speed would be around 280 knots. How many of you understand? Correct. Now in this calculation, see, my engine has failed. I am going back home, or my engine has failed and I am going to destination. Understand? So when you are calculating CP, O and H, O comma H, which are ground speeds, outbound, and ground speed homebound, these are reduced speeds. Reduced ground speeds. How many of you understood why you have to use only reduced speeds? Correct. So note down distance to CP. You solve this equation yourself. Don't see and note down dH by O plus H. Now in exam, do you have this much time to solve all this? No. From now on, even if I wake you up in sleep and ask distance to CP, dH by O plus H, O and H are reduced speeds. What is the distance between departure to destination? Okay, and you sleep. You have to memorize this, but you have to understand also. Clear? So note down, you have how many of note down, you have 1 minute time to note down everything. Okay, don't note down this. I'll tell you time. What is this? Just give me 1 minute. Sir, are you comfortable till now? Any doubts? No doubts. Good.
Sir, can you explain the last line? When engine fails, outbound or homebound?
Yeah. So let's assume in question they have given which aircraft do you want to fly? Don't say Cessna, it has only one engine. If you are going to fail, you are going to land there. Which aircraft you want to fly?
It was 380.
737, A380. Which aircraft?
A380.
A380. Okay. Let's assume A380 has a TAS of 400 knots. Okay. This TAS is produced if all engines are working.
Okay.
Correct. So this is 4 engine TAS. Now, if there are nil winds, what is the ground speed?
400 knots.
4 engine.
400.
Yeah. So with 4 engines, it is 400 knots. Okay. Now, at a CP, you have an emergency. Your captain is also having a heart attack, and you want to go forward or back. Now your one engine failed. Okay. Let's say A380 with 3 engines will fly at only 350 knots.
Okay, sir.
Now, see, if there are nil winds, what is your ground speed?
With 3 engines, it's 350.
Yeah, with 3 engines, it is 350 knots. Correct. Now, assume you have a headwind of 10 knots. Now,
Yes, sir.
tell me, headwind means when you're going like this, you are facing a headwind, correct? Tell me, what is your H and what is your O? What is your homebound ground speed?
Homegrown like 360 and outbound is 340.
Very good. See, if you turn around because you have a headwind, it will become your tailwind and it will carry you forward with 10 more knots.
Yes, sir. Got it.
Now you have 360 and O is equals to 340. Now, see, you did not take 4 engine TAS. You took 3 engine TAS when calculating your ground speed, correct? With nil winds, because you assume at CP always you are also going to, your other engine is also going to fail.
Yes, sir.
So when doing calculations, you input O and H this way using reduced speeds, not full TAS, not 4 engine TAS. Okay, you take 3 engine TAS. Okay, so any doubts in the example I explained? No? Note down here. Note it down, everyone. Good. Now, acha, let's assume Raghu is sitting here. Okay. और क्या रघु कैसे चल रहा है? सर ये लोग ना कोरोना के वजह से मेरा एक काट दिया, सैलरी आधा कर दिया, मेरा EMI तो कौन भरेगा? पैसा चाहिए? नहीं जी सर, नहीं. Okay, we are talking. Okay, we are having a coffee. Raghu, coffee. He is also having a coffee. Okay, chilling in the airport before the flight. Okay, now I'm pushing Raghu. Here, let's assume. Okay, Raghu has given me this critical point is at 600 nautical miles. Okay, Raghu is a dispatcher and he doesn't know that which aircraft I am flying. Okay, maybe he knows. I'm flying a Boeing 737. Okay, sir, आप ना कितने टाइम के बाद पहुंचेंगे आपका क्रिटिकल पॉइंट? ठीक है, मैं ऐसा आपने कितना बताया था क्रिटिकल पॉइंट, कितना डिस्टेंस था? हाउ मच डिस्टेंस वाज द क्रिटिकल पॉइंट? He said, sir, 600 nautical miles. Okay, so 600 nautical miles. See, I'm flying a 737. I have like headwinds of, let's say, 20 knots. Okay, so my TAS 737 can produce is like 2 engine TAS. With 2 engines, with both engines working, you can produce a TAS of, let's say, 400 knots. So what is the this is the headwind, correct? Minus 20 knots. So what is my ground speed?
380.
380.
380. So I'll do 600 by 380. Okay, and whatever I get, I'll give him. यार इतना घंटे के बाद मैं उधर पहुंच जाता हूँ. ठीक है यार, when I am thinking after how much time I will reach, will I use 2 engine TAS or will I use 1 engine TAS?
2 engine TAS.
2 engine TAS, correct? Because see, I am calculating the time to reach CP. Understood? See, if I have to go to CP and come back, I will assume here worst case scenario, their engines will fail. But if I'm sipping a chai with him and he's just asking me here, when will you reach? Okay, this is my TAS, this is my ground speed. By this time I'll be there. Okay, see, you are still going to your CP, correct? Engine has not failed. You will assume engine fails once you reach your CP, or once you decide to come back or go forward because of an emergency. How many of you understood? So that means while calculating time to CP, okay, so while calculating time to CP is equals to distance to CP by outbound speed full ground speed. How many of you understood? Clear? Note down. Time to CP is distance to CP by outbound full. Okay. Here there are other names also for CP. Here it is also called as critical point, is also called as point of equal time. That means to go forward, also to go backwards also it will take equal time. So that is called, that's why it is called as point of equal time. Here from now on, I'll never call it as a critical point, I'll call it CP. Sometimes I use PET, In your exams also, you don't see CP sometimes. You see only PET. What is PET?
Point of equitime.
Point of equal time. There is one more thing which you can rarely see in exams, that is equitime point. All this means the same. Critical point, CP, point of equal time, PET, or equitime point. Shall I move forward? Okay. Till now, any doubts you can ask. If you want me to start, sir, start from the start. Okay. Someone say that I'll give you 10 times homework. No. Okay, fine. Do this question. Okay, let me modify this question. This is task with 2 engines. If this is task with one engine failed, or let's say this is single engine operating. Okay, let's say Boeing 737. That means one engine failed and it's only one single engine operating. Now task is like 150 knots. Okay. It is not a Boeing 737. It has task is very high for Boeing 737. Your landing speeds are around 200. Let's say it's a small aircraft. Okay. Now solve this question. You have 5 minutes. How many students are there in class? Right? 1, 2, 3, 4, 5, 6. But officially we reached like 20 students on this batch. So 2 or 3 students will be joining from 2 or 3 days. Fine. I'll be back in 5 minutes. Until then, you calculate.
I get option D195.
Here, forget options. Answer will not be in options.
Sir, I get option D195.
You got option B.
Delta.
Delta. Okay. I don't know. I have to calculate.
Sir, CP has one name PET, point of equal time, and the third name was
CP?
CP PET, and the third one was
Equitime point or equal time point. See,
So I'm getting alpha.
Sir, I got also for actual question and after changing
No,
the
no, no,
stats
don't
to the
calculate
150
actual
knots,
question.
I got
Don't calculate actual
for
question.
this 150 knots, I got 162 nautical miles.
150 waste here, waste here. Everybody getting different answer means if 3 people answer and 3 answers are different, 2 people are wrong. Worst case scenario, 3 people
I
are.
have solved the test 180.
Then why? I have said na.
Sir, actually I got disconnected.
Okay, sorry.
Sir,
Calculate.
with
calculate.
test 150 answer is 162 nautical miles.
Let me calculate. See, now put your pen down, everyone. Time's up. Time's up. See, I'm going to do the answer in a specific manner. Okay. So I want you guys to give me homework when I give you again when I give homework today. Solve all questions in the format which I am doing today. Okay, because in exam I don't want you to confuse what is H, what is O. So always write down. So like this, you're going from A to B, correct? Write down where is A, where is B. That means A is your departure and B is your destination. Clear? Now the distance is 360 nautical miles. 360 nautical miles. Always write down like this. Correct? Let's say this is your CP. Put a dot for CP. If you want to mark it, you mark it as a CP. Now from here, if you're going home, this is your homebound speed. If you're going out, this is your outbound speed. Correct? Now, for 2-engine TAS is how much? 180. Correct. 1-engine TAS is how much? 150. So now, what is the formula for distance to CP? DH by O plus H, where D is the total distance. D here is 360 nautical miles. What are O and H? O and H are? O and H are? Answer please. Huh?
150
Outbound
minus
homeward.
50.
One second. They are reduced ground speeds. They are reduced ground speeds. Correct.
Outbound is 185.
Wait. See, what is the TAS? TAS with 1 engine, which you have to consider now.
150.
150.
Okay. So your aircraft, your ground speed is TAS minus winds or TAS plus winds. Okay. Your TAS is, if you're going outbound, let's calculate outbound first. Your TAS is 150. The wind component A to B, that means you are going outbound like this. It is headwind or tailwind? Headwind.
Headwind.
Is
Headwind.
minus. How much it is? 135.
135.
135.
Okay. If you're going home now, your TAS is reduced, correct? Because you are calculating CP. O and H are reduced speeds. So 150. Now it is plus 15.
165 knots.
165 knots. Okay. Nobody will hold your pen until I say, Sanisha, look at the screen here. Now,
Sir,
yeah.
please tell me one thing.
Hmm.
How do you calculate the like 1-engine TAS from 2-engine TAS? How are you doing that?
I gave it in question here. They will give you in question. Okay.
1-engine TAS, where is it written?
Single engine operating. You are not attentive. You are writing down something.
Okay, sorry.
Okay. Fine. But thanks you have asked it. At least now it is clear. Okay. What is the formula for distance to CP? DH by O plus H. Correct. What is D now?
360.
360. What is H now?
165.
165. 5. What is O plus H?
165 plus 135. 300.
165 plus 135. Okay. Now see, everybody open your calculators. Okay. This is how you have to enter this. You calculate it, 60 into 165. Numerator.
360.
Wait.
Sir, it's
Wait. Okay, sorry. It is 360, correct? 360 into 165. Okay, clear?
130.
One?
165 is correct.
No, actually it's like 135.
No, H is 165. Right?
H is 165. Now you are going home, correct? When you're going
Okay,
home, you are going
sorry.
from B to A. It is tailwinds. H is 165. So this is what the confusion happens sometimes. You enter O in place of H. That's why I want you to always write down O outbound, H homebound. So you put 2 dashes like this. Clear? Shall I calculate this? Now, see, if you have to do this, and then you have to 165 plus 135, you have to calculate, and then you input all values and divide, it will take a lot of time. Correct? So I don't recommend it. 360 into 165 divided by, see, in the bottom, there are 2 or 3 values, correct? So open a bracket always. Open a bracket and add 165 plus 135 and close bracket. Everybody input the same value or same method into your calculator. Everybody could do it. Let me know. How many of you got the same answer as I got? Raise your hands. Okay, everyone is raising the hand. How many of you did not get the same answer as I got? Everybody got it? Good. Now calculate time to CP. Calculate time to CP.
So 1 hour 12 minutes.
Okay.
One hour 6 minutes.
What is this? Yeah.
1 hour,
Two
6
different
minutes.
1 hour 12 minutes.
Two different answers. One is wrong. Someone is wrong.
1 hour 6 minutes.
Okay. Ravi Kumar, how did you calculate? What is time to CP?
Distance to CP by O full. Like I calculated, distance to CP is 90.
198 nautical miles. Okay. What is O full?
Is full task with 2 engines.
I'll kill you. I'll kill you. With what? I'll kill you with my pencil. Sir, is it TAS or ground speed?
Ground speed.
Ah, pilots here, not Aam Aadmi. To talk in pilot language. Okay, it's a ground speed. Okay, so which TAS will you use, with single engine or 2 engines?
2 engine.
2 engines, correct. So 180, and you're going outbound or homebound? You're going to CP or coming from CP? You're calculating sitting on having coffee, talking with Raghu, correct. So you're going outbound, correct. So outbound you have a headwind of minus 15. So your ground speed would be 180 minus 15. That is how much?
So
160.
198 double 165, 1 hour 12 minutes.
12 minutes.
1 hour 12 minutes.
So open your calculators. 198 divided by 165. You will get 1 hour.
Sir, it's 198, not 168.
Oh, sorry. 198 divided by 165. 1.2. Is it 1 hour 20 minutes?
1
One
hour
minute.
1 hour 12 minutes.
12 minutes.
0.2 hours is 12 minutes. You understand? So it is 1 hour. And how did you get 6 minutes here, Ravi Kumar?
Sir, I haven't included the headwind component.
Oh, I thought, okay.
Need a base.
God is your friend. God has no wins today. No. I add him. Okay. Fine. Very good. Anyways. So any doubts till now? How many of you want break? Raise your hands. See, number one. Yes, Anisha. I also want break. Take a break. I'll see you at 1:30. Okay. So come with fresh brains. We are going to discuss a lot of different concepts in this only. You will love the concepts.
So I was noting it down.
Oh, okay.
Please.
I'm sharing. 1 second. Everyone. How many of you know this song? No? It's a very good song here. Fine. Guys, come back here. Fast. Oh, always late. Anyway, until others come, we'll complete the song actually. Okay. So I said 1:30, correct? Now you just know how Raghu calculated sitting on the ground how much time it will take for the aircraft to reach the CP and how much distance or where is the CP on the way. Clear? Shall we move forward with this discussion? Correct. Okay. See, on that day, Raghu thought there are no winds. Okay, so he have seen a METAR, correct? So Raghu is the dispatcher, correct? When he was calculating the DCP, distance to CP, METAR said 0 winds. If there are no winds, where is the CP on this line? This is the
At the midpoint.
At the midpoint.
yeah departure, and this is the destination. So if there are no winds, why is at the midpoint? Because your homebound speed and your outbound speed will be equal. That is nothing but your ground speed or your tax. Correct? Clear? So if they say no winds, or if they say O is equals to H, distance to CP will be midpoint. How many of you understood this? Raise your hands. What are beam winds?
Crosswind, which are 90 degree to the aircraft.
So beam winds are nothing but if the winds are coming exactly from 90 degrees to the aircraft track or path. They can come like that or they can come like this also from this direction. But they have to come from 90 degrees to track. Correct. So sometimes you see a beam winds. Beam winds or a beam winds, both are same, no difference. Clear? Beam or a beam, the words are same. Okay. Tell me.
Is there any difference between beam winds and crosswinds?
Yeah, there is a lot of difference. See, crosswinds are, for example, if you are trying to land on this runway, you will come like this. Now, if the wind is coming like this, so a wind component is giving you a headwind, wind component is giving you a crosswind. A crosswind is generally used for landings when the wind tries to push you out of the runway like this. Okay, so here you don't use abeam winds because see, the wind is not exactly coming abeam to you. It is coming at an angle where one component is like a beam, and these are generally used for landings, and this is a crosswind. But if you say beam or a beam means they are exactly 90 degrees to your track. For example, if your track is, let's say, 045 degrees, tell me from where the abeam winds come. This is your track, your aircraft is flying 045, means from north. Okay, if this is north, you're flying on a track of 045. From where the winds will be abeam? What is meant by abeam winds?
135.
From
Very good.
135 degrees.
So if the wind is coming from this 135, that will be abeam winds. And this side also
215.
315.
Sorry, 315.
clear. Very good. Tell me, guess what happens to distance to CP in abeam winds? Winds are exactly coming
Will
from,
stay like that, sir.
will it stay at midpoint or will it move?
At the midpoint only.
Okay, so he says it will be at the midpoint. Now tell me what happens to time to CP?
Will increase, sir.
Oh, very good. Now explain. Your both answers are correct.
Sir, like we are facing the beam winds, right? So we grab into the winds. So in that way, the time to CP will increase.
Okay, that I understand. But how can you say the CP will lie at the same place at the same midpoint? Why?
But as we discussed earlier, like CP will concern with only head and tail.
Sir, we are maintaining the same track.
Hmm?
Sir, we are maintaining the same track by grabbing into the winds.
Will tell you. See, if you're flying like this, let's assume from here the wind is coming. These are abeam winds. Understood? Now what happens to the aircraft? If you maintain, let's say this track is going east or the track is 090, correct? If you maintain your heading also 090, correct? That means your nose is exactly 0.090. Because of this winds, your aircraft will be pushed sideways. So your final track will not be 090. Probably it will be 10 degrees to the right. So 100 degrees. How many of you understood why the aircraft is moving forward? Now, here, see, if you're flying from Hyderabad to Delhi, here you don't want to land in Kolkata. Correct? You want to go to Hyderabad only. What do you do? Instead of flying like this, you do something called as crabbing into the winds. Here, what is crabbing into winds? See, instead of putting your nose like this at 090, you crab into the winds like this. You put your nose. See, if you don't do anything, you are drifting off by 10 degrees due to winds. Correct? Instead of putting 090 degrees, you put 080 degrees. That means you put your nose into the winds. Correct? So you're trying to fly like this, but the winds are pushing you like this. So ultimately, you will still be on the track. Now, can someone say what is the disadvantage of this? See, your task is in this direction. Your aircraft is trying to move in this direction. Now the wind is coming like this and trying to stop you and push you towards the track. Correct. So that means your ground speed, it will be less. How many of you understood why ground speed will be less? Raise hands. How many of you did not understand why ground speed is less? Ask. Anyone?
Sir, once again.
Okay. Anil, if there are no winds, okay, the aircraft is moving forwards with a TAS of, let's say, 100 knots. Clear? Now, what is the ground speed?
100 knots.
Now, the winds are abeam. There are winds. Correct? Now, if they are, let's say, making your aircraft go like this, drift off like this. To prevent this drifting, you're crabbing into the winds. That means you put your nose like this. If the drift is, let's say, 15 degrees, you crab into the winds by 15 degrees. So you are trying to fly in this direction with a speed of 100 knots. Am I clear on it? But what is happening? See, you're fighting with the winds and winds are pushing you like this. You're maintaining the track, but your direction or your speed is 100 knots in this direction only, not in this direction. See, in this direction, it is 100 probably cos theta, cos 50 or sin 50, something like that. Understood? That means here your speed on the actual ground will decrease. Okay. How many of you understood this? Here, everybody here attended CX3 class. Okay.
Yes, sir.
Okay, fine. First scenario, no winds, TAS is 100. How many of you agree? Okay. So second scenario, your track is 090 degrees true. Your winds. Here, where are the winds coming from? North, correct? So let's say it is 360. Winds are coming from north at 15 knots. Okay, your ground speed, you don't know. Okay, so when winds are nil, when nil winds, TAS is equals to ground speed. Correct. In first case scenario, your TAS, let's say it was like how much? 100 knots. So your ground speed is also 100. Till here, everybody clear? Let's say your TAS is 100. Okay. Now input this and find out your ground speed while you are flying like this. Open CX3, everyone.
Sir, 98.87 knots.
Okay. So you are go to which section?
The wind
Wind
correction.
So your TAS is 100. Now you are going on a true course of 090. The wind is coming from
15. The
where?
speed. The
Wind
speed.
speed is 15.
15.
Wind direction is
15.
law 0. Okay. So your ground speed is 98. So in this case, 98 nautical miles per hour. How many of you understood this? That means, see, your ground speed from nil winds, it was 100, but now your ground speed has decreased because of beam winds. Till here it is clear. Assume you're going from departure to destination, correct? And if no winds, your CP was here. Now there are beam winds like this. Okay. Now imagine something happened and you have to go back or forward. If you're going forward, you're doing this. Agree? If you're going backwards also, see, because the winds are there, you're crabbing into the winds. How many of you understood? So that means here your speed O is decreasing by something, H is decreasing by something, but both are decreasing equally. Correct. So that is the reason your CP will still be in the midpoint in abeam winds. Okay. So in abeam winds, no winds and O is equals to H, CP will still be at midpoint. See, for example, see, in abeam winds, let's say your O is 45 knots. No, not 45. Let's say it is like 95 knots. Correct. What will be the value of H?
Sorry, in beam winds.
In beam winds, it will be
Also
same,
95 knots.
same 95 knots. Correct. So O is equals to H. So it will still be at the midpoint. How many of you understood? Raise your hands. Now, see, write down in beam winds. In beam winds, correct. CP will be at midpoint. Now, see, again, you and Raghu are sitting and discussing yet. Raghu, today it is beam winds. Okay. Now tell me, what happens to time to CP? See, CP is still at the midpoint. Agree, everyone? Now what happens to time to CP? How much time it will take to reach CP? Will it increase or decrease?
Increase.
It will increase because see, your ground speed is decreasing. Correct. Time to CP is nothing but distance to CP by outbound speed. So outbound speed is decreasing because you're crabbing into the winds. So time will increase. Correct. Right on in beam winds, CP will be at the midpoint, but time to CP will increase. Any doubts till now? I'm willing to explain it again. No doubts. You see, there is one paper. See, DGCA has around 9 or 10 question papers for navigation. That's all. There is one paper where CP PNR questions are very tough. There are like around 15 questions in that same paper. And whenever students get that paper, like they say, sir, it is very hard. So that's the reason I'm like trying to push everything into brain very carefully. If you have any doubt, if you don't understand a concept, please ask me now. Am I clear? Am I clear? So you don't read or someone doesn't teach you with this clarity. If that paper comes, you are going to fail.
Sir, you told beam and abeam are same, right?
Yeah.
Okay. Sometimes you are using abeam and beam, so I thought a little bit confused.
I wrote beam and I wrote A. Beam and abeam are same. Okay.
What did you say? CP will be at midpoint and distance to CP will increase.
Time to CP will increase.
Time.
Yeah? Time, na? Time is increasing. So you're done with your sorting?
No, sir, I didn't have a sortie. They just called me to sign in
Okay.
the some bond. I don't know.
Now, see, when he was discussing with Raghu, okay, Raghu said there are no winds today, sir, you enjoy. Okay, aram se go and fly. But see, his navigation display on the cockpit is showing that I have 20 knots headwind now. So this is the midpoint. Okay, now where is the new CP? Is it here or is it here?
Towards the red arrow.
Towards
the
right.
destination.
Can someone explain why? I want you guys to explain me why. Your answer is correct.
Sir, at the point of CP, we have equal time. T1 equals to T2.
Okay.
When we get headwinds,
Mhm.
time from our departure to our CP point, it may take speed is decreased now because we are getting headwind.
Good.
So
Good.
time increase.
Yeah. So here, see, if you're turning back here, okay, you have a tailwind. If you're going forward, you have a headwind. Correct. So this time will be more when compared to this time. So this time will be less, this time will be more. But our definition is time should be same. If you take here, in this direction, you are going fast, but your distance is more. Correct. So time to CP is distance by speed. Correct. Your speed, but distance is more. Here, your distance is less, but speed is also less because of headwind. Correct. If you're going in this direction. So both ratios will be same and your CP will be here. New CP will be here. So in this case, this Arjun, the Captain Arjun was at the midpoint. Okay. So he took a right decision. He came back to Chennai and landed at Chennai. Okay. So that first officer could save this captain, and that captain is still alive. He had shown me the photos which they took in the hospital. Happy ending. To be frank, Arjun is my son. I created this story. Raghu is my best friend. I made him dispatcher. Okay. So that I waited at the Chandigarh airport. A pilot really came out after 6 hours of waiting. But he said, I remember back then I was like very much financially tight. He said, I don't think you will be able to complete with the money you have. This will not be sufficient. He just gave me like 30 or 40 seconds and it just looked like this and he left. That's the real story. But I believe that you understood everything. Correct. I don't remember the pilot's name that day. See, anyway, despite all that, I'm here. Correct. Story has a good ending here. If not, the story did not complete. Okay, story abhi baki hai. What was the movie name here?
Om Shanti.
Om Shanti. So nice. This thing. Clear? Okay. Mine in this life only I'm doing it. Okay. Fine. Okay. So he said on the RT, pan, request immediate turnaround. I'm coming back to Chennai. And you gave the pan. Clear? How many of you understood till now? Okay. Now from this, can I say CP always moves into events?
Yes.
Correct. So CP always moves into events. Correct. For example, in this case, if it was a tailwind, he was at the midpoint. Now he is having tailwind. So where is the CP? Closer to the departure or destination?
Closer to the departure.
Why? Because see, it is easy to move forwards with tailwinds, but if he has to come back, it will take a lot of time. So from here, the distance is less, but if he is turning around, he has headwinds. From here, if he is moving forward, distance is more, but he has tailwinds. So CP moves into the winds. So tailwinds, it will move towards the departure. If headwinds, it will move towards the destination. Can I say position of CP on the track will depend on the winds? Correct. So CP is a function of winds. Now, I will ask a stupid question. Please don't mind, because you have to today it may look stupid, but tomorrow when you come to PNR class, you will be cleared why I have asked this stupid question. For example, this guy, while flying from Chennai to Colombo, he needs only half tank fuel. His tanks on the wings, he needs only half of them to be filled. Now, if he carries tank full fuel, will his stats change? Will the engines perform better? No. Correct. It does not matter how much fuel he is carrying. Correct. CP will always be there. CP does not depend on how much fuel you are carrying. Tomorrow we'll be discussing something called as PNR, point of no return, that depends on fuel. Correct. So write down CP is a function of winds and it does not depend on fuel or endurance. Okay, I'll explain this concepts tomorrow. Clear? Fine. Shall I move on? Do this question. No, these concepts are beautiful here. I really love when teaching these concepts. Answer, please.
So is it 500 nautical miles?
Nope. Someone gave the answer in the chat.
Sir, option D.
Option?
Delta.
Who gave the answer?
Answer.
How? That's the correct answer.
Sir, from the first equation, we calculate our
Oh,
speed.
you know your TAS, you know your ground speed. How did you calculate?
Sir, we know
Oh,
total
oh,
distance,
Okay.
small d.
Okay. You don't know your TAS, correct? How can you calculate the ground speed? You just know the winds.
Sir, we know we can assume x.
You can assume X. It will become two big equations, and you waste 1 hour in
No,
exam.
sir.
Okay. So you are saying distance is equals to distance to CP is equals to DH
Yes,
by
I did the same.
plus H. correct? 100, sorry, 1000 into H is home, correct? This is 600. Then you will assume homebound is, okay, in first case it was 10 knots headwinds, sorry, 30 knots headwinds, correct? So into,
X plus
let's
30.
assume
X plus
TAS
30.
is X,
X plus 30.
headwind, correct? Home, yeah, X plus 30 by X plus 30 into plus X minus 30.
Minus.
Time's up. Exam is over. Okay. We are not doing algebra. We are pilots. We don't know any mathematics. We don't want to know because what? We have this. Okay. Even in
So-
our exam, they are allowing calculators.
So
No
we
algebra.
can do one thing, we can equate both the equations and get
No.
a smaller ratio.
No. See, it is a concept I just taught it. Let's say I'm going from, let's say I want to go to Delhi. Or let's say I'm going from A to B. Why do complicate? If there are no winds, where is the CP?
At the center midpoint.
At the center midpoint. Now, they say you have 30 knots headwind. Okay, if you have headwind, CP will move towards B or A?
Towards B.
Towards B. Correct. So in this case, now this is the CP at 600 nautical miles. So this is not the CP, this was the midpoint. Understand? Now, I said CP always moves into the winds, correct? Because you have a headwind, CP is closer to B. Till here, everybody understood. Now, this headwind was 30 knots. He said, if headwind component changes to 30 winds tailwind component, understand? So he is saying here headwind to bhul jao. Okay. Now the wind is coming like this. Same 30 knots. See, the CP will be on this side. Agree, everyone? Correct. See, with this 30 knots, CP moved into the wind by 100 nautical miles because midpoint is 500 because he gave total distance as 1000. Okay. Now with the same, if the winds are changing, if there are no winds, it is at midpoint. So if the winds change exactly, CP will also move exactly, but in opposite direction, correct? So this will be 100 nautical miles. Now, what is the distance to CP?
400 nautical miles.
400 nautical. So when this calculating x plus y is equals to x square plus y square. Oof. We have pilots here, we don't know shit. Okay. Sit in the aircraft, autopilot dabao, it will fly. Use less brains. Good for health. Am I clear on this?
Excuse me, sir.
Yes, sir.
So what if they change the winds? Then too we'll have to do that, no?
Yeah. See, this is a hypothetical question. This is a question created just to show that yes, CP always moves into the winds. And note down, if tailwind changes to headwind or headwind changes to tailwind. So that's why I kept arrows on both sides. Okay. CP will move to the other side of midpoint by same magnitude. Is this line understood? The explanation for this line is this whole question. Am I clear on this? Shall I move forward? Note it down.
Yes, sir.
Sanisha is writing here. How many of you have completed jet streams in meteorology? I'll explain. Answer this. We'll do these 2 questions and I'll end the class. And I'll ask you one more question.
So is it Bravo?
Nope.
C.
Okay. See, I'll tell you what is North Atlantic tracks. What is a tap here? There are a lot of planes. You can see real time.
Flight radar.
Yeah. Sometimes forget names. See, this whole area is Atlantic Ocean. This part is called as North Atlantic Ocean. Correct. So there are 2 very prominent cities. On this side, it is US. On this side, it is London. Correct. Now, when you're flying from London to North America, correct, you're traveling westwards. When you're flying from North America to London, you're flying eastwards. See, this track is very important because here there is no runway or no proper communications when you are mid-Atlantic. The only communication you have is HF radio, which is not very powerful. Nowadays, you are using SATCOMs. You know what is a SATCOM, correct? Probably in the radio navigation, you will know what is a SATCOM. Satellite communications. Okay. So, flight from US to London, at some point of time, probably this pilot who is now here, he doesn't have contact with either Toronto or he doesn't have the contact with London also. So he is 99% on his own. Correct. If he has to communicate, he has to use HF radio, which is not very good, and probably SATCOMs if he has. Understood. So these are North Atlantic tracks. Like these are the routes which are flown by very much experienced pilots. Correct. When you're flying over North Atlantic tracks, see, you have like I'll show you how the wind blows. These are live aircrafts and live wind, correct? So generally, if what was that aircraft here? Boeing? No. 787. Okay. Now where is it cruising? At what altitude? 39,000 feet. Flight level 3990. Correct. Now let's see the winds at flight level 3990. Okay, flight level 3990. Correct. Now Can you make out where is North America and London? Yeah, this is correct. See, what is the wind direction? So this is probably London. Okay. I'm not able to make out what is what. Okay, so this is US and this is London. Okay, if we take to flight level 3990. Okay. Now, what is the direction in which the winds are blowing? Normal direction. Is it are they blowing from west or are they blowing from east?
Blowing from west.
Blowing from west. Now let's see what is the wind speed. 96 knots. A Cessna cannot land when the speed is 17 knots or 18 knots. Correct. When the crosswind is 18 knots, it cannot land. What is the speed of wind? 96 knots. Here, these are not normal winds. These are called as jet streams. Okay, I'll be discussing all these winds in detail. You will understand why this form, how they flow, how they are causing rain in India. Correct. Whatever rain we get, we are getting from this jet stream only, which is currently flowing there. Correct, in the monsoons. I'll discuss that in meteorology. Correct. So these are called as jet streams. Jet streams generally flow in west direction. Correct. Now coming to my question, see, this is North America. This is your London, North America. Correct. So these tracks are called as North Atlantic tracks. Now, if you are cruising at flight level 3990 or generally at the cruising level, the winds always come from the west. So these are called as westerly winds. Wind direction is always based on from where they come. Understood? So if your aircraft is flying like this, your aircraft is flying east. But the same direction, if the winds are blowing from west direction. So these are called, given a name, westerly winds. Understood? The terminology is completely different, which I'll be discussing entirely in meteorology in detail. Correct. Now, let's say this is the midpoint. Okay, this is the midpoint. Tell me, where will be the CP?
Towards North America.
Towards North America.
Correct. Will it make a difference? You're flying this direction or this direction?
We are
No,
flying
correct.
easterly.
Correct. The thing is, like, whether you're flying from North America to London, CP is here because CP moved into the winds. Whether you're flying from London to North America, still CP is here because it moves into the winds from the midpoint. Correct. CP is only a function of winds. It does not matter whether you're flying from A to B or B to A. How many of you understood this? Correct. So CP is always nearer to North America because usually always all around the year winds are westerly in the North Atlantic tracks. Am I clear on this? Did you understand? Okay, I'm trying to mix this thing, the knowledge of your navigation with meteorology. Correct. Do you want to mix it with technical general also? Okay. So next question. This I am mixing with technical general. Okay. And next question I will mix with common sense. Wait for the next question. Okay. Answer once you understood this question. Okay. You answer this question, please. Question number 8. Your option delta is wrong. Insufficient. There is sufficient.
Alpha.
It's alpha.
No. Sir, is my voice clear? If I'm moving here and there, I'm talking.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Mic is stationary. Now, yes.
So B.
What?
B.
Correct. When A is not the answer and D I eliminated, it will change. So option is B, na?
Option A.
I said B is correct. Someone is saying option A. Okay, teach. You only teach the class. Okay. Let's see. Aircraft is flying from A to B. Right. Better performance is obtained as the aircraft climbs up. Here, what is performance? What is performance? For example, you have a car. Okay. So, what is performance?
Mileage.
For example, I have like that is
We
performance.
get maximum output in a given amount.
You get a powerful
More
output.
power.
More power. Correct. Now, see, your flight between two places is divided into three parts. One is your takeoff. Next is your cruising. Okay. See, takeoff will take 2 minutes. Your cruising will take 1 hour, and your landing will take around like 5 minutes. So most of the time you will be cruising. Understand? Understand? Now, see, I'll discuss takeoff first. If this is the aircraft, okay, so I'll take this direction. Okay, my aircraft is taking off like this. Let's say this is the wing of the aircraft, cross section of the wing. Okay, as the aircraft moves forward, see, the wind should accelerate above and below, and it will create a pressure difference, and this will generate lift. How many of you understood? Okay, I'll explain this in detail in technical general classes, but this is the basic how the lift is generated. Now, if the aircraft is moving forward and the wind around the aircraft is also moving, because now the aircraft has tailwinds, correct? What happens to the effective wind flow on the wing? Will it increase or decrease?
Increase.
See, aircraft is trying to move forward, correct? So it is trying to make wing go in this direction. Now, the wind is tailwind, so wind is trying to come in this direction. अंशी जी, एयरक्राफ्ट आगे जा रहा है, विंड क्या कर रहा है? विंड भी आगे जा रहा है. विंड क्या करना? विंड के ऊपर जाना है ना, पीछे. करेक्ट? समझ गया? So the lift decreases. How many of you understood that? So when the lift decreases, the ground speed, the aircraft cannot take off here. The aircraft will take off at this point. Because see, the aircraft has to move so much fast on the ground so that the wind moves on the wing and lift is generated. How many of you understood this? Everybody? Everybody? So that means you cannot take off in a tailwind. Sometimes the runway will not be sufficient to accelerate so long. Always take off are into winds. How many of you understood? Okay. Now tell me, landings, do you want to do it into the winds or with the headwinds or tailwinds?
Tailwinds.
Headwinds.
Who said tailwinds?
The headwinds.
You know how scary it is to land in a tailwind? Do you know, Shreya, experience landing
I
in
got
tailwind?
caught. You wouldn't believe, sir. It was my fourth solo check, and the winds suddenly picked up, and it was my third landing, and tailwinds came. My instructor was very scared, but then he asked me to reduce the
Will
speed
it
and all
push
that.
down or what?
I'll tell you.
It's like when you cut the power. How do I explain?
But still it will be gliding. It will not, like, even when
Yeah, I had to
floating,
maintain
it will come
65
too
knots.
fast.
I just had to glide. Yeah.
Yeah. Cut all the power and see what happens is, see, I'll explain that also. Let's say this is your runway. Okay, you're coming to land here. Okay, now see, you land with as less speed as possible. Why? Because if you land with more speed, your braking action will not be sufficient to stop you at the end of runway. So you have to land with less speed as possible. Now, see, if you come low on speed, too much speed, low on speed, the airflow will separate and your aircraft will stall. That means it will freely fall on the ground. Okay, and your aircraft probably you will lead to a crash. So you have to maintain a speed where you don't stall also, you are not fast also. Understand? Now see, if you are having headwinds, your lift is generated because the wind is flowing over your wing. Correct. Let's assume your landing speed which you have to maintain is let's say 50 knots. Okay, now if you have a headwind, that means wind is coming like this with speed of 10 knots. Correct. You can just maintain a TAS of 40, and anyway headwind is coming with 10 knots, so it will flow 40 plus 10. The speed of wind on your wing will be 50 knots. Correct. So not TAS, it is ground speed of 40. Clear? So you will touch down with the ground speed of 40, but the speed of wind on your wings is 50. So you're not stalling. How many of you understood this? Okay. Now, for example, you have a tailwind. Okay. So you have to maintain, see, you have to maintain wind over your wings of 50 knots. Okay. Let's assume 50 knots. Okay. Now you have a tailwind. That means wind is trying to push you with 10 knots more. Now, what is your landing speed? Ground speed while landing?
60.
Correct. You're moving with 50 and 10 knots. Tailwind is pushing 60 knots. Correct. Let's say that means you are driving a car with 180 kilometers per hour. 40 is approximately 180 if I assume double. Ground speed, you're driving a car, 40 is only, okay, you're driving a car with 130 kilometers per hour. Which is more scary? 130 or 80?
120.
Yeah, 130, correct? So this is more scary. Okay, so this is more scary. So tailwinds, landing, you come very fast, and generally if you try to slow down, you are prone to stalling. Correct. So you will touch down very fast and you will need a longer runway to stop. So that means both your takeoffs and landings has to be into winds. That means, that's why when you take off, you always check. What do you check, Shreya?
So the windsock.
Yeah, you always check the windsock, that wind should be blowing towards you, and then you take off into winds. When you're landing, just before the approach, you make sure the windsock is into the winds. So that means the wind is coming like this, you will land into the winds. How many of you understood this? Correct. That means, see, when you're taking off, if you have headwinds, you will easily take off and climb faster. If you have tailwinds, you will take off late and climb slower. Correct. So your performance of the aircraft will increase if you have headwinds. How many of you understood this? While taking off and landing. But it is different while cruising. See, while cruising, you need tailwinds. Correct? You need tailwinds. Why? Aram se it will push you. So cruising needs tailwinds, and takeoff and landings needs headwinds. Am I clear on this? Now read the question carefully. You're flying from A to B. Let's assume this is A, this is B. Better performance is obtained when the aircraft climbs up. That means, than you imagine, headwinds are more or less. Better performance means more headwinds. Correct. So originally you thought from A to B it will be tailwind, but now performance is increased, that means you have headwinds. Correct. If CP was here, CP will move into winds. Correct. So new CP will be towards B. New CP towards B. CP moves closer to B. How many of you understood? Okay. So this is combining navigation with technical geography. No doubt. I'll ask you one last question and I will take a break till tomorrow. Is everybody comfortable?
Yes,
Yes, sir.
Very good. Very good. Who wants to participate in this next question? Raise your hands. Okay. I'll give option to, I have to give to boys only. Boys raise your hands. Okay. No. Girls raise your hands. Okay. Girls. Okay. Manchi, which airline you want to work for?
Sir, Indigo.
So from where to where you want to do a flight today?
Delhi to Chennai.
Delhi to Chennai. This is Delhi. You're going to Chennai. You are at midpoint. You are at midpoint. Okay. Now you have headwinds. You have a passenger with heart attack. Okay. Now, will you go forward or will you land in Delhi?
Sir,
Answer fast.
where is my position?
Midpoint. You are exactly at the midpoint.
Sir, towards Chennai.
You have a headwind here. If you go to Chennai, it will take a long time, no? I'm not asking the position of CP. I'm asking whether you will go to Delhi or will you land in Chennai?
Sir, Delhi.
Delhi. Everybody agree with her? Raise your hands. Boys,
Yes, sir.
don't raise. Boys don't raise. Giving clue. Don't raise. Girls, raise your hands. Okay. So how many of you agree girls have no common sense? See, boys, agree? Imagine girls are not there and let's talk. है ना? Common sense नहीं होता है ना? Here, when you have a heart attack, okay, and for example, your captain is having a heart attack, do you think from midpoint you will go back to Delhi or will you just land in Hyderabad and take him to hospital? Vanshi, what is this here? See, critical point is only used when you don't have an alternate airport. That's why I said Chennai to Colombo, somewhere here. Over water, you cannot land on water. No? There is no hospital on water. Correct. That's why I said North Atlantic tracks. Going from London to, see, you land in Hyderabad. Note down, critical point is calculated only when you don't have an alternate airport. Understood? So this is combining navigation with common sense. Got it? Fine. Any doubts you may ask? If not, I'm hungry. I did not have my breakfast yet. It's 2:30. No doubts?
Sir,
Hmm.
I have a doubt from math class.
Yeah.
Sir,
Google.
small doubt.
Okay. Ask.
Sir, in the previous class, we did a test in which there is a question isobar of surface charts related. You told we opted the option QFE.
Question number?
Sir, maybe 26 or 7.
Okay. Okay.
You told the answer QFE, right? But sir, in Oxford, answer
It is given QFF, no?
Yes, sir.
And I'll confirm this answer.
Okay, sir.
Okay. Fine. Any other doubts? See, both are correct. We normally use QFE, but more exact correct is like QFF. I'll solve this. Okay, I have noted this down. Okay. Any other doubts? Then today's class. Today's class. No. Okay. Fine. Take care. Bye bye. And how is Met going here? Metrology.
It's fine, sir.
Yes, Sanisha. I can see your expressions. I have like 2 big monitors.
It's fine.
It's fine. Fine, sir. I'll see you guys when? Today, no Met class. Do you want a doubt session for Met class? No.
Sir, not today.
Not today. Okay, fine. Tomorrow. Okay, tomorrow come with fresh brain, sir. Here, tomorrow, na, I'll teach easy concepts and one concept which is very difficult. Okay, so our advantage would be like I'll teach you which no other where nowhere like is not taught anywhere else. Okay, fine. My own creations. See you tomorrow, guys.
Thank you, sir. Have a good day, sir.
You too, guys. Have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye. Bye bye.
Thank you, sir.
Bye.